Hi everyone. For this screencast, I'll be building a basic block explorer showcasing the usage of the Selenium API that allows for accessing all data on the Celestia blockchain. All right, let's do a quick walkthrough of the finished product. So this is a dashboard which shows on-chain metrics. So the latest block height, total number of transactions on-chain, and total number of addresses. Then we show the last 10 transactions, and we can also click on the signer address to load the accounts page, which shows you the account balance, if there's any delegation and bonding, and the last in transactions that address has executed. For this particular project, I'll be creating a single page app using the Vue.js framework and also utilizing Tailwind CSS to make everything come together nicely. For devs following, make sure you have an up-to-date version of Node.js installed. I believe at least version 20 is required. If that's all set, let's create a basic Vue.js app by executing the following command. So here we'll fill in the details of the project. So all we need to do is to change into the directory. And then we just need to do npm install to install the dependencies. Okay, so all the dependencies have been installed. I'm going to switch over to VS Code so we can start working on the code itself. And we can also run a terminal from within VS Code as well. So this is a project. Let's create a new terminal within VS Code. Okay, so once you have the terminal, we can now by running npm run dev, and this should create a local server with a link that we can browse the actual app that was created. And we'll make the necessary modifications to improve on this. So we can go ahead and start a new terminal as well, because we need a few additional packages for the project. First is Axios, which will act as our HTTP client. So we can go ahead and install Axios by executing now that is installed. We need to go ahead and install Tailwind. So we'll install Tailwind CSS by using npm So once that is installed, we just need to initialize Tailwind CSS. So we'll do that by executing npx Tailwind CSS init-p. So this created this Tailwind config right here, along with this post CSS file. The only change that's required for the config is to add the following content. So this now allows for Tailwind CSS styles to be added to the index.html file and all source files. Now we need to go ahead and create a style.css file within the source assets folder. And within this file, we need to import the Tailwind CSS styles. The next step is to modify this main.jss file to import that style. So we'll change this from main to style.css. Now that we have Tailwind CSS installed, we can add some root styles to our index.html file. I've created this repository with a number of template files where you can simply copy the contents and follow along with the screencast. So the first major step is to add the necessary template structure to our app.view file. So if you go to the 02-app.view file in the templates repository, you can simply copy over the contents there to the app.views file. So you can delete this and simply paste contents there. If we go to the site, we should see a change. So for the dashboard, we want to show some basic on-chain metrics. Alright, so we can remove the contents of the home view file, and you can go to the templates repository and copy the contents of the 03-home view file. So the structure of the file is very simple. You have a header showing you the name of the page, and so this is showing that we are on the dashboard page. We have a section here for on-chain metrics, another section for transactions, and another section for blocks, the latest 10 blocks. So let's firstly start working on getting the on-chain metrics, which would simply cover the current block height, the total number of addresses on chain, and the total number of transactions. Let's go and create the address.js file, and you can find the contents for these files in the templates repository, 04 to 05 files. So this would be the basic content of the address data store file. So we're bringing in the data store function, which will be used to create the data store, and this will be exported so that can be utilized in our components. So within this, we've created a state, and these are the state variables. So we have address count, loading, so we can show a loader, and error, we can display an error on the screen if there's one. So there's only one action right now, and that action is to fetch the address count. So what we're doing here is using Axios to make a call to this API endpoint, which will retrieve the address count. So if we go here, we'll see that the current address count is this value. So if the response, the status is 200, which means it's successful, then we will store the count in this address count variable, which we can then use within our components. So one thing to note is that for all the data store files, they will have similar state variables and similar functions, with the only difference being that the API endpoints would be different. So there's a lot of duplication of code here, which can make maintenance and updates more challenging and error prone. A better approach would be to refactor these state files into a single reusable model that allows customization of the API calls, which would cover the don't repeat yourself principle. But for this basic example, we proceed with the duplication of code for simplicity and simply just focus on achieving functionality first. So we can create the other two files. We will have one for block and the last store, which is for transactions. So let's go ahead and create our first component. This will be the on-chain metrics component, and it will be pulling in the count data for transactions, blocks, and addresses from these stores that we just created. So let's go to components, new file, call this on-chain metrics.view, and the 07 file within the templates repository will have the contents of this component. So if we look at the template, we'll have a header showing the on-chain metrics. We'll then have a section showing the current block height. We're getting the block count, transactions, the transaction count, total addresses, the addresses count, the address count. So all that we're doing, we're pulling in the transaction store, the use store function, the use block store function from the block store, data store, and same for the address. And then we have various other components or functions that we'll be pulling from the view package to create these computed values. Okay, so before anything is done, this unmounted lifetime hook is called. Call this function fetch data, and what this function fetch data does is to call the respective fetch count function. So for the block store, it's fetch block count, transaction fetch transaction count, address fetch address count. And then once the data is fetched, meaning that the API is called, then we go about creating this computed value based on that. So within the block store, we're accessing the block count state variable, and we are using this to local string function to add the necessary commas to the value. So now we can go ahead in our home view and import the on-chain metrics component. So import, we can call this on-chain metrics, and we're pulling this from the components folder and on-chain metrics. And now we can use this on-chain metrics here. So if we go to the website, we can see that our on-chain metrics are being loaded. So currently the block height is 3.5 million, total number of addresses 1.5 million, total transactions 27 million so far. So that's looking good.